Hey Matt, how you doing?
How's it going?
Doing grand here. It's a nice day in South Carolina. Here we're going to talk about some crazy stuff today.
Yeah, so I wanted to bring up a topic which everybody talks about. In fact, this weekend, I've had messages all over the place asking about this. The funny thing is I'm not actually military, so I've never come across this. So what I would do is I'm going to use the I am dirty word in exoskeleton development,
No.
Iron Man era.
No.
I think what we should do, I think we should have a bit of a conversation about where did it start from, where did it go, and I suppose not what's gone wrong, but where are we up to? Exactly
Right.
what is happening in the world?
Right.
And of course, it is the so-called Iron Man dream. Why can we not fly yet?
Ah. Well, I would argue we can do it one time, but the landing's going to be horrible and somebody's going to get hurt probably.
Yeah, yeah, exactly. It's not gonna be nice. It's
It's
not
gonna
gonna be
be
nice.
like the
Although
it's gonna be like just like the first Iron Man movie. You know, it's like a bottle rocket up in the air and then crash in the sand, and that's exactly where we are, right?
Yeah, yeah, yeah. That's as far as I know as well. I mean, and then sometimes I look at Richard Browning, some of the
Yes,
stuff
of
he's done with
course.
the suit. It's very cool stuff. Very cool. I mean, it's closer,
Yeah.
but it's not quite what we're seeing in the Iron Man era. But I mean, really, the earliest version that I can find of anything that's remotely to do with this surely is the '60s with
Yes.
GE.
Yep. The Hardiman again. I mean, it sort of starts this whole powered exoskeleton thing from the beginning.
Yeah, I mean, to continue from what we talked about last time, just looking at the Hardiman itself and the overall approach of it. Now, I am right in thinking that there were two competitors, were there not, at the same time, or roughly around the same time.
I'm not sure. I mean, I knew there was there were two parts of the government funding the GE effort, but I don't know if there was another competitor to GE. Maybe I mean, you might be right. I can't recall, to be honest.
If I remember rightly, I think it was called the Man Amplifier,
Correct.
and I think it was done in a university, and they
Okay.
were looking at it was almost like pneumatics. They were
Yes.
pushing a lot of air between joints to create that displacement to give that actuation point. But everybody knows that the first real powered first exoskeleton for military application in for logistics and moving load carriage and so forth was GE's Hardiman.
Right.
Hence why it's in the Guinness Book of Records as being the world's first powered exoskeleton.
Right.
However, we all know it also didn't work.
Well, I
So
mean, it's parts of it worked. It never worked all together, right?
mhm, that's right.
But like, the pieces of it, like, well, at least the hand. I can't say the leg. The legs were, that was a bit sketchy. But the arm and the gripper seemed to work really well. They did demonstrate that. Now,
Did
the power was not on the actual Hardy Man. It was off to the side, basically, completely like, basically hooked up to a pneumatic generator and everything. The arm was like fixed to the ground, so the person wasn't actually, holding up the weight of the arm. But it worked. It did demonstrate the concept.
yeah, it was an umbilical, was it? It was like umbilical to the ground, wasn't it?
Yes.
Like powered in that way. And somebody coined it the monster era, which I
Yeah.
find quite funny because it's all the time of like Godzilla and things
Godzilla,
like that from the sea.
Mothra,
It's
yeah.
exactly.
Ultraman. You remember
Oh
Ultraman?
my God,
Yeah.
yeah, yeah,
Yes.
exactly. But I mean, it failed, didn't it? The
Yes.
Hardyman overall as a piece for the baseline of the legs, it just wasn't it just wasn't safe
Right.
to be used for that type of application. And I've done my homework to try and look to see if there's anything else I could find where military exos was seen again, and I couldn't find anything really between the '60s right through to the noughties.
Yeah.
Get to the noughties, and then it tends to really kick up. But let's face it, you go through that period. Actuators are finding their home. Microelectronics are getting
Right.
used to being used. Microcontrollers don't really
Exactly.
appear until the 80s because the Silicon Valley, the
Exactly.
big, you know,
The
this will
big
change
boom.
the world.
Yeah.
We hit the noughties. Now we're looking at smaller microcontrollers, and this is where, yeah, I'm going to tap onto you for this because this is the type of stuff that I've only been reading about.
Yeah. So
Um,
this is the early 2000s when they start doing, somewhat what's called the Hulk program, and
mhm.
they're again basically putting a robotic exoskeleton on a soldier and doing it for, from what I understand, for it looks like a dismounted type operation. So that's your regular kind of soldier moving around, running through the mud, carrying a rucksack, backpack, whatever you want to call it, carrying their weapon, that kind of stuff.
So, the Hulk and another one, Sarkos. Have you heard of Sarkos?
Oh yeah,
Is
so,
this
yeah,
this is the big chunky like
yeah,
looking machine? Is that right?
yeah, exactly. Full body kind of exoskeleton. I mean, Sarkos had a powered exoskeleton for years and stuff like that. I'm not sure they're still doing that. I think the company has switched over to doing more AI related type things, but they did
Okay.
have a powered exoskeleton for a number of years.
Right. Yeah. 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 Because I do remember, I do remember in the early noughties where there was a guy doing like I think he was doing like push-ups or something
Yes.
in the robotic structured
Right.
suit.
I mean,
So I'm like,
the issue was is like, the way I understood it, Matt, is that it's the weight. So and I don't mean the way the exoskeleton. So soldiers are still carrying like a huge amount of weight, even though they're now carrying like 110 pounds of lightweight gear. It's still 110 pounds, So the R&D keeps making the gear lighter, but the soldiers keep packing, they keep
more
packing
and
more
more.
on, so
Wow.
the overall weight doesn't change that they're carrying. So that was what I understand that program was really about. It's like, can we take some of that load off of the soldier? Go ahead.
Yeah.
Sorry to
Okay.
interrupt.
Yeah. No. 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 So the Hulk suit, was that designed for total dismounted soldiers? Then do
Yeah,
you know?
yeah, and it was to design to the way I understood it was designed to transfer the load to the ground. So, take the load of the rucksack and all that
Mhm.
and transfer that to the ground so the soldier's back and knees and ankles aren't bearing all of that weight.
Right. Okay. What went wrong?
It's the same thing I believe that's gone wrong with everything since Hardiman, which is physics. Is we haven't come up a good way to fix the power to weight ratio. We can't generate enough power without adding additional weight to the soldier, and it never balances out. That's the same thing like the next project you're probably going to talk about is like the Talos, which is supposedly the modern day Ironman one, which
Yeah.
ran into the exact same issue as power to weight ratio.
Right. Yeah. Yeah. So, the funny thing is anybody who's watching this is a massive Iron Man nerd. If you read the volumes of Iron Man, you'll know one volume is purely dedicated to the problem of control.
Mm,
So the whole nerdy side of this on the suit, they try to target. Tony Stark tries to target the actual way of controlling it,
right.
and he finds that when he moves his arm, the suit doesn't react quick enough,
Mm-hmm.
which it sounds really outlandish, but when you actually look at this as a real problem,
Yes, current
this
problem.
is also the same. This is a real, genuine problem that we face.
Yeah. I mean, it's a current problem with exoskeletons right now. It's not fantasy whatsoever. There's probably at best in commercial systems, you probably have on good days you probably have like about a 300 millisecond delay between what you want to do and then it reacting to that. Some
Yeah.
will argue that they might can get it a little bit shorter time, but that's under very ideal conditions from what I understand. So 300 milliseconds is probably about the best you can do, and that is enough for your brain and body to notice the difference, and that's part of the problems with current exoskeletons.
Right. Right. So that really pans on the idea of that. When you look at even early stage with Hardiman,
Yeah.
when you look at some of the reports and they talked about its unstableness of it, if they were battling with the way that the time of the system responded, as well as the unpredictability of their servos, it just kind of shows why they said, let's not put anybody in it, just through the risk of it, quite severely injuring somebody in the process.
Right.
Okay, yeah, so that really makes sense then. So I'm guessing that any type of dismounted soldier approach would be the same thing.
Yeah, and
Because
the argument has been is like maybe that's the wrong target. I've heard a lot of people say this that's worked in DoD. It's like, maybe while well-meaning and probably they learned a lot of things going through the Talos program, because it wasn't just about giving a suit that could carry extra basically body armor. It was about all the things to go together, because some of it was about physiological monitoring, being able to know the health status of the soldier, the connections in between, because there was two parts of the suit. There was an underlayer and an overlayer, being able to connect those kind of things. So there was a lot of, I would say there was a lot of good research and knowledge that came out of it, even though the overall project wasn't a success. And so that's the other thing with a lot of these things. Just like the Hardiman, even though the overall project wasn't a success, the amount of knowledge that came out of it was amazing. And we're still in that progressing forward. But back to my point is like, what I've heard from a lot of people is that they probably should, instead of going after what's called a dismounted soldier, they should have gone after soldiers that do like logistics or something like that, that's not out there in very unstructured environments, away from
yeah,
power, away from accoutrements that would support a exoskeleton as they currently are today, versus being out in the wild as they tried to do.
yeah, I suspect that's surely one of the most hardest things. I mean, anything that I've come across has always been the hardest thing, trying to predict people's motion.
Right.
And the more that they're in a more uneven environment, so something like a forest or something like that, where the grounds are uneven, it's such a challenge to try and come up with a way to complement that person's motion if you're thinking of a hard exoskeleton.
Right. Well, and the other thing is like, this is part of the strategic concept, and this makes it hard also. If you make an assumption, and this is where everybody's kind of failed. So I don't say I have a solution for this, but if you make this assumption, which is the exoskeleton's going to be turned on all the time, so every time you move, it's going to know you're moving. Every time you do something, it's going to either try to assist or get out of the way. You're using power, and eventually you end up with, hey, I have to carry so much battery weight to be able to do that. This doesn't make any sense. That's what's happened for a majority of them in the modern day age, from what I understand.
Yeah, yeah. So it doesn't really balance up the juice for the squeeze, as
Yeah,
Rita would
yeah,
say.
yeah. And it's like, okay, if I want to do this with current power capabilities, then I have to look at a different strategy. And I would argue you got to look at a strategy where it's not on all the time. It only comes on when you need it. Is probably something closer to what you need.
Yeah, yeah. Because obviously, from what I'd seen, and for the work I'd done in the past, speaking to some UK military personnel,
Mm-hmm.
they'd always talked about that. Really, they didn't want batteries.
Right.
They never wanted battery because there's one extra thing to be concerned about.
Right.
And then one guy once said to me, "Look, if I had to pick between ammo that's going to save my life and the team's life, and your batteries, you know which I'm picking." And you
Right.
kind of go, "Yeah, that's a hard truth, really, isn't it?"
Right. Right. Yeah, I'm totally down with that. And it's, especially if you're carrying one more battery, and it's like, it's just one more thing to deal with. It's another logistics type tale that you're going to deal with. It's like, okay, it just keeps adding on issues. And so
Yeah.
if you're going to come up with a smart solution, you have to deal with that power issue, because that seems to be, no matter how good our microcontrollers are, matter how good our actuators, our materials, we can design this thing out of, ultra lightweight titanium foam, make up some crazy thing. But if we don't fix the power thing, it doesn't matter.
That's right. Yeah, that's absolutely right. If we're not able to really iron down exactly the power side, it doesn't matter what we're doing.
Right, and that's the key thing. And the other thing is, like, matching up capability to need. So where is it actually needed? Where can it do the best versus where do you want to stick it? Where do you want to stick it for the pictures? May not be where it's actually needed.
Yeah, exactly. Yeah, so I mean,
don't get choked up. I know you get emotional.
Yeah, I know. I'm
about
just
all
getting
this.
choked up with the whole thing right there. It's just so much to take in.
So I mean, you talked to the UK MOD and some of the folks in Europe a lot over the last couple years. Where are they kind of thinking that there's a need for exos?
So it was quite interesting. I mean, I've some of the people I'd spoken to. I was at an event, and I was lucky enough to be at an event where NATO were discussing which direction they were going to take some of their approaches. And one of the heads came in and he said, "Look, this is to the whole room." He said, "Look, I am not an expert. I'm not an engineer. I'm not a designer. I'm not an innovator." He said, "But I know what the ground needs. I know what we need."
Right.
And he reamed off a list. He said,
Nice.
"Look, we need human augmentation, we need robotics, and we need drones."
Right.
And that gives an overall of, basically, it's like an IoT soldier unit where you've got a bit of robotics and a wearable robot or an exoskeleton.
Right.
That was really interesting, because then I'm sat with these others, and I walked up to one guy and I said, "Look, we're making an exoskeleton. It's going to support you on the ground. Would you wear it?" And he said, "My freedom to move allows me to feel free. So I work out, I exercise, and I exercise." And he said, "This cognitively makes me feel safer." He said, "If I'm going to put something on that's going to slow me down," he said, "I mentally think I'm not safe." And he said, "What I do is I compromise myself and the rest of the unit."
Right.
When you sit there and go, "I've done all this time for no reason. What the hell am I going to do?"
Yeah, exactly.
Really interesting side. Then surrounding, and then in front there's a woman, redhead, and she must have been height of around only 5'4", 5'5".
Right.
She wasn't a huge woman. Yeah. I mean, just on normal civvy clothes, you're talking like 70 pounds. There's nothing to her, really. Right. Then she told me that when she's fully loaded up, she can be 150 in some cases, because they're carrying so much. Wow. And then she said to me, she said, "On the field, I'm a combat medic." And you go, "Okay." And she said, "If you can help me get to this guy," the guy was a really big guy. Yeah. So "if you can help me get to this guy and get him off the field, where do I sign?" Right. And when you go, aha, we were looking at the wrong place here. We're entirely wrong of where we're actually looking. Yeah. So then what I did is I traveled back to the UK and I spoke to one of the Northwest brigadiers, right, who's the head for the combat medics, and actually looks strategically where combat medics in the UK are going to be going if they're out serving. Right. And he said to me, 54% of the UK's combat medics are women. And you go, right. And then he said, statistically, the second highest people discharged for medical failures and ailments is women with lower back pain. Wow. And he said he couldn't put a number on exactly if it was coming from combat medics on the battlefield. He said, but from his experience, this will definitely be something that needs to be considered. So emergency evac, when I spoke to her in whenever at the NATO event, she said that when she's on the field, they are the first line of attack. So the enemy will be looking to think, well, if we can take out the medics, the unit's very susceptible to injury.
Right.
And it's a scary environment, isn't it? And so when they said it, and then I came back, and then I was able to get a feel for others as well. So I knew people from reserve units of other units in the UK, and I spoke to them, and they said the same thing as well.
Wow.
They said, boots on the ground, you are wasting your time. They said logistics, so load carriage of moving large equipment,
Right.
like on, say, pop-up bases, things like that, great. And they said combat medics, 100%.
Wow.
So that's my experience of seeing what I'd seen. And but when you dive deeper into who needs this kit, it tends to, from what I've seen, it tends to be a real more focused approach. That's going to shoehorn nicely into the next topic I was just going to move on to.
Yeah. So I have to ask, it's like, so we've gone through a few of the Marvel comics. It's like, so we did the Hulk project, we did the Iron Man project. What name are we going to give the project for the combat medics? You know,
Yeah, we need. Oh,
you got to
that's
have a
great
name,
one.
right?
We've got to have a name. That's really cool.
Yeah, I mean,
oh yeah,
there's got to be a good character name that's going to fit for the combat medics, because it's not Iron Man.
Yeah, exactly. It's not Iron Man. So anybody who's a huge nerd,
that'd be us.
behind me, I've actually got a rebuilt Rescue helmet. And Rescue was the female Iron Man
Oh,
that
nice.
Pepper Potts wore. So the suit is called Rescue because it has no weapons on board.
Oh, cool.
The idea is that she was there to just rescue people who needed help.
Right.
So the argument is it the Rescue project?
Wow, that would be pretty cool. That would be cool.
That's really cool, isn't
that
it?
would really line up with everything. I mean, you think, it's like, if you were running this project, like, where would you start? I mean, with all the things, you know, we've kind of looked at with Hardiman, with the Hulk, with Talos, where do you start without, you know, basically repeating what's already been done? You know, what is, you know, what if you were making an argument, and I'm not asking you to give away your company secrets here, but if you were making an argument for money, you know, and say, hey, we can do this, and here's why. What has changed in the technology world that makes it possible?
Ooh, now, it's a big question,
Right?
So I think first though we just explore Talos, a little bit further,
Okay,
and then we come back to that
right,
point.
I'm good with that.
So I'm only coming at this from a nerd of Tom Clancy. Love Tom Clancy and Splinter Cell. And every time when I learned about Splinter, and then I'd heard of this Talos project, I was like, what the bejeebers, this is amazing.
Right.
But I don't know an awful lot about it. I mean, I've only really just been trying to learn about it as we speak. And am I right in saying that this was a U.S. Special Forces?
Yeah, so
suit?
it was sponsored by SOCOM, which is Special Operations Command. It had a number of researchers and companies, universities and companies involved. It also had one of the big manufacturing USA institutes called NextFlex, which were involved. They were involved in they do what's called hybrid electronics, flexible hybrid electronics. So think of like the smart textiles. So they were involved with the project, from my understanding, of creating the underlayer suit that had a lot of the physiological sensors and was going to be the interface to the overall suit. So there were a lot of parts and pieces to this project. It was a big project.
Yeah, well, nice.
Yeah.
So, from what I've read, this system was going to be like a heads-up display. It was going to support the actual soldier, going to keep them cooled. It was make them basically undetectable under certain environmental states. And
really, I didn't
hear
like, that part.
The trouble is some of the websites I've read it from, you know, you look at it and go, I think you guys are making this up.
I think I'm really making that up because yeah, I tell you what I heard, you know, is it was supposed to be. I hate to say this, because I'm going back in superhero characters. It was still sort of like the idea of the Hulk, and it was still in that kind of mindset of how can I put more body armor. So if I'm a tactical assault, and I've got, let's just say, 60% body coverage, which is pretty darn good. But I'm number one or number two through the door of the bad guys. and I can increase that from 60 to 80. That's a win. But that 60 to 80% body armor coverage is a lot of weight, which would slow me down, which puts me at, like your point earlier, puts me at greater risk. Slower is more dangerous.
Yeah.
So the idea was that Talos was going to change that game, that I could go up to, let's just say 80%. I can't remember the exact number. 80% PPE or body armor coverage, but I was going to keep my speed. That was, so you're going through the door like an armored tank, basically, is what I'm trying to get at.
Yeah. Wow, that's insane. That's incredible.
Right.
Am I right? Because this was just me reading, because you can never trust 100% anything that you read on the internet. Some of the actual references go. But am I right in saying that the project itself came to a fail just for the many same reason of batteries?
Yeah, that's my understanding. There were other issues, I believe. It's some people would also attribute how some of the acquisition and integration, some of the administrivia was done in the project. There were some challenges there. And I'm not trying to disparage anybody that worked on the project, because this was a Herculean type effort, to use another superhero reference here. But the issue it's like anything that's really complicated. The more you part out something complicated, the more likelihood you're going to have something that doesn't interoperate well. And I heard that was another issue, is there was a lack of interoperability, because you had different companies producing different parts of the suit, and that caused a whole different challenge than just the power.
Yeah.
But the power was the big thing.
My earlier days in my career, I did a lot on looking at Formula One cars. Did a lot looking at engine mounts and the way that interfaces across. And one thing that we'd often taught when I was a university lecturer was the idea of that if you don't talk to each other, you'll come away with things that don't fit.
Right.
May look really cool separately, but together looks just a joke.
Yeah.
It just doesn't work.
Yeah.
But I wrote down this quote from one of the experts from the Talos project, and that is, the suit would be awesome, but the soldiers would be crushed under the weight of the batteries needed to run it.
Exactly.
Can I go, let's not use that.
Yeah, that sounds pretty bad. It'll be great for the photo op, but that's about it.
Yeah. It's basically Hardiman again. So like, just pose in it.
Yeah, just pose in it, right. Yeah, I mean, if they had fixed the suit to the ground and put all the weight on the ground, then yes, the soldier could use it, but they can't move.
Exactly. So you just don't move.
Yeah.
So I think that shoehorns nicely into what you were saying of where do you think it could go?
Right.
So Hulk, Sarkos, GE's Hardiman, the Talos project, one major commonality that was a big problem there is power.
Yes.
Batteries. Every military personnel that I'd had the privilege to speak to, they'd all said, it's great, but don't give me millions of batteries. Right. If it'll help me, cool, I will wear it, but don't give me millions of batteries to put on. And that was coming from the combat medics. So it makes you wonder, is the secret in all this? I hate it because it's not a hybrid design. Is it the passive system with active components that can redirect it? So is that where the secret lies?
Yeah, I mean, you've got to do something to address and I would say the first thing you have to do is kind of define, okay, what kind of window are you trying to provide power within? Is it a 3-hour window? Think about, when we first got laptops. If you had a laptop that lasted 3 hours, you're like, oh, wow, that's amazing. And now it's more like, hey, if they don't last the whole day, they're not so good.
Yeah.
I mean, we're kind of in that kind of thing is, so how many hours should the exoskeleton last for the combat medic or the logistics person? Is it 3 hours? I would argue is probably closer, especially for a combat medic, 72 hours. And so, okay, once you fix that number, now you have to go through and start, okay, how do I manage the power to make this work without adding layer upon layer of new batteries? Because adding new batteries is kind of the bad part of this.
Yeah. Yeah. And I mean, I did a podcast a few weeks ago, and I was asked the same thing on that side of that. There is a quick rush, isn't there?
Yes.
Everybody else said, well, let's just stick an actuator on it. You kind of go, should that main focus not be really on the human body and then looking at design to complement the motion of that body, or focusing on an action, not an overall job?
Right.
So this one size fits all is just too brave.
Well, and the other thing is there's a lack of appreciation of sort of like what you're getting at. There's a lack of appreciation of the actual person. Don't help a person where they don't need help. If you have a combat medic and they're strong in these areas, they may not need any help in this, but there may be some little b areas like, like for everybody. If I start to stumble or if I get off balance, there's probably some places in that kind of movement where they could use some assistance, but they're regular stuff that they're really good at. That's not, while it may be a little bit of strain on them, they're accustomed to doing. Don't try to fix everything,
I mean, I think my real thing is don't give somebody who's got bigger biceps. What the point is that?
Right.
If you look at the major spots of failure around a human body when you're, I don't know, lifting something up, it'll always be your lower back. Right. So surely that's a nice target spot to try and support.
Yeah, I mean the other one I would argue, and it's just I've had this happen 1,000 times over my lifetime. It seems like, is your grip. If you can't get a good grip on something, no matter what the weight of it is, it can become awkward and hard to handle. Almost everybody's probably had this. They've had this probably some piece of furniture. It's not that heavy, but it's hard to get a good grip on it, and then it becomes this awkward thing, and you end up hurting yourself on something that's lighter than something that would actually hurt you because of the weight, and it's all because you don't have a good grip on it.
Yeah, and you're just constantly battling with that.
Yeah.
That and another one, knees. The level of knees, damage on knees. It all tends to be the lower part of your body. So it makes me laugh thinking about the quote from Ralph Mosher of "Let's do the legs afterwards because that won't be too difficult." When they did the Hardiman.
Yeah, it's so funny. Yeah, the legs are the easy one, right? Yeah. As we watch all the humanoid robots face planting, for years, and probably still will face plant for a while longer,
Yeah. No, absolutely.
Yeah, balance is, I've told people this in, our little community. It's like, balance is the killer app. I mean, it is in exo world. If you can help someone with their balance, you can give them power. That's, and that's what I would argue in a combat medic. It's like, if you can help them with their balance, where they're carrying, what they call asymmetric loads. That means the stuff ain't even,
Yeah.
You got all the weight off the one side, which is not what you want, but that's where it is. So how do you help them out,
Yeah, well, I mean, I was looking into a test that they call, New York police call it this. I think they call it the drag test.
Oh yeah.
Where they'll grip for the ground, they'll drag a weight across a certain distance.
Right.
And you look and go, there's so much there, and that in an action is a huge action in itself. Anyway, if you're referring to logistics, right through to pulling somebody injured out of the way.
Right.
So it just kind of shows these types of areas are where it should be focused on, not trying to create the super soldier.
Right. Yeah, just it's simple stuff. Now, what do you think as far as power? How long before we get something better than our current batteries? I mean, I know I'm asking kind of sci-fi stuff here because I just don't think, Elon's real smart and everything, and they're doing a lot of amazing stuff with power, but I don't see us getting into a handheld fusion reactor anytime soon. So what's in
Yeah.
between, you know?
Yeah, I mean, any types of batteries that I've seen over the past year, past year, year, month two,
Yeah.
um, any types of developments I've seen recently, they tend to be just slight modifications to squeeze that little bit more out of operation.
Right.
I don't know. I mean, there's some great things that you see come out from different areas around the world. Batteries, let's face it, are the big
Right.
you know, they're the big secret weapon to everything. Once we can nail battery technology, so much more we can do with it.
So
But to really know, it's hard.
yep. So let's go back to back to the movies where we can get into safe space and not be held accountable for accurate information here. So Independence Day.
Oh yeah, yeah.
Yep. Yep. So all of the alien spaceships
Hmm.
didn't have batteries. Were powered from the mothership up in orbit. So basically, the
Oh
power
yeah,
beaming is what we have
yeah.
today here, but that was some form of power beaming from the ship. Is that a possibility?
That's the point. That's the point. Because I mean, if we're going to go to the sci-fi element, I mean, we're able to do wireless charging, aren't we now? But that's where
Correct.
you've got contact to contact. I think Tesla not once try something
Yes.
like this
Yeah,
where
there's
he
actually
kind of,
patents from Nikola. We're talking about Nikola Tesla, not Tesla, the
yes.
car company.
Oh yeah, apologies. Yeah. We also Nikola Tesla. Yeah,
Yeah.
because and yeah, I knew I'd heard of where he was aiming to build this big like power unit to show power beaming.
Yeah. I
So he,
believe it is at War Warfendale or Warfen. I cannot remember the name of it. It started with a W, and I believe he was funded at the time by I want to say Rockefeller or somebody like that. Uh, but he was building a big tower to do a wireless transmission of power. But again, I don't know if and we're talking about a considerable amount of power. I'm not sure anybody's been able to demonstrate that's safe. You know, it's like
yeah,
I don't want anybody like aiming a microwave beam at me because that will cook your insides for sure.
yeah, yeah. Am I meant to feel this warm?
Yeah,
No, put a jacket on.
yeah. Don't worry about it. You're just charging up your
Yeah.
exo.
Don't worry,
Yeah,
don't worry,
yeah.
don't worry.
You
It's
keep
all for
shooting me with
science.
that thing, I won't need the exo. You're gonna kill me.
Yeah. Well, all the metals melting around you.
Yeah, exactly. You're charged. Oh, thanks. Now.
But I mean, as a concept approach, I don't know. I don't know. I mean,
Yeah.
that level of approach towards it makes you wonder. I mean, recovery. Is
Right.
there a way to recover kinetic motion more
Yeah.
in as we're moving forwards?
And I mean, it's like, think of like the Toyota Prius and cars like this called hybrid cars where they do regenerative braking and stuff like that. Yes, a little bit of power is recovered, but it's never enough to fully recharge. I mean, you you kind of run into that. You're almost saying you've got a perpetual motion machine if you say you can
Yeah,
really
yeah,
generate enough to really recover per se where you were. You never get back to where you were because it's always a decline. Just just physics. So unless you bring in some power from the outside, there and saying you're based off battery power or something like battery power,
hmm
you're always going down. There's never a get back
yeah,
up to where you were before. You can get a little bit up. You can get
yeah.
like you
It's a
said
losing battle.
you can get a little bit. You can slow it down, but I don't think you ever stop it declining.
Mhm. Yeah, a bit of a losing battle, really, isn't it?
Yeah, yeah, and that's kind of the tough part about this. Now certainly the microelectronics are getting more and more efficient, which means you're drawing less power over extended amounts of time. That's a win. Absolutely, there's nothing wrong with that. Um, That's not magic.
Yeah.
That's just better design, better efficiency.
I think that's where that really lies. When we refer to it, I think now you have micro. I was having this discussion earlier. Actually, you've got these microcontrollers now that will run on 3.5 volts, and it's just drawing so much less that these things will go forever.
Right.
But the idea of this thing sitting there and deciding whether the actuator needs to be turned on or off means that you've got like a battery management system that can choose whether this needs to be turned on or off and actually work with you. And I think that's where all this lies.
Yeah.
It lies in getting up that response system to be quicker. And it lies in the microcontrollers doing the best job possible to give you that assistance when you need it.
Right. And you know, it's funny. It's like we have things in our house that sort of almost everybody does, or they should. We have things in our house that sort of prove this concept, because almost everybody has a smoke detector in your house. If you don't, you should get one. And most smoke detectors are 10-year smoke detectors. They have a battery life of 10 years.
Yeah.
So, and I get it. This is a very low power utilizing type detector, but I mean 10 years. So if we can do that, it shows the possibility of being able to manage power and not have to increase battery size, battery weight for these types of devices. That's, to me, is like the big hope.
Yeah, it is. And because that's the big aspect. It goes right back way to the original soldiers I spoke to. They didn't want extra batteries to be carried.
Right.
They didn't want to be carrying extra pieces. And if you can convert this into a way so it's so efficiently used, in theory, you could put the batteries into the clothing that they're already wearing. So they're just putting their clothing on as usual.
Right. Exactly. And you know, again, I'll go a little bit into sci-fi realm, but there's a way to collect energy also from basically the body heat from soldiers, because they're putting in an external power source, which is food. So they're eating food, converting that food into energy in their body. They are producing heat to keep them at a certain temperature, but they're also producing some excess heat from when they move around.
Yeah.
That is another area where you could, as you get electronics more and more efficient, it becomes an opportunity to collect things. Inefficient electronics, you're wasting your time. You'll spend more energy trying to collect that heat than anything you would get off of it. But as the electronics get efficient enough, that becomes another opportunity of recovering a little bit, in my point of view.
Yeah, so it just kind of gives it that idea of it's all the efficiencies, isn't it?
Yes.
It reminds me of when I'd seen some students, they were looking at the Shell Eco Marathon Challenge, where they're given a liter of fuel to drive as far as they can with just one engine, and they've got to design the vehicle as to be as efficient as possible. And it's a similar aspect, but in exoskeleton design and extending that lifespan to get the best out of it that's possible. That's instantly, though, made me think about a topic for our next podcast.
What's that?
100%.
What's that?
Control.
Oh my gosh, not the controls.
We've definitely got one on the next books, which is control.
All right. Well, if we're going to talk about control, if we're going to go get that nerdy, you're going to have to bring out the Ironman helmet. And we'll talk about the controls in the helmet and the AI, and then we'll talk about, regular nerdy stuff.
Yeah. We'll go right the way through. We'll go heads-up display to... I laugh because this is the funniest. The most common one that you ever hear in exoskeletons. Why is everybody not using electromyography?
Why not?
And
why not? Why aren't you using EMG? Well,
let's get on to that one. And then let's get on to EEG, so reading the brain waves.
Right.
And then let's get on to how we actually do it.
Right. Yeah. Let's get on to what we actually do.
Yeah, what we actually do.
Yeah.
And what works.
Yeah. We're about skilled at reading what dogs are saying as reading EEGs and EMGs for exoskeletons right now. That's,
Yep. Very, very, very true. Yeah, very true.
Well, cool, Matt. I'm looking forward to it. Control. I think that will
Yeah,
be
definitely
an
the next
excellent
topic. Looking forward to it.
All right,
Looking
take care.
forward to it.